Let's start. Hello all. Let's start with our today's DSA Journey with this amazing sheet by ChaiCode.com at DSA.ChaiCode.com. Use this link to get a 7-day free trial. Okay. And today our question is this one. Apple harvest or cocoa eating bananas. Given a pile of banana and a fixed number of hours, find the minimum constant eating speed bananas per hour that lets you finish all piles within an hour limit. Each hour you eat from a single pile, and if a pile has fewer bananas than your speed, you spend a whole hour in it. Okay, so this is our question. Okay, so what the question says, 3671, like 3671, 1 or 11. Okay, 11. So this is actually the number of bananas given to us of every pile. Okay, so pile number 1 has 3 banana, pile number 2 has 6 banana, pile number 3 has 7 banana, pile number 4 has 11 banana, and we are given an hour which is 8. Okay, so 8. So our task is to finish all the bananas in 8 hours. Okay, but we can eat a specific number of bananas every hour. Simple. Like let just take one thing, take 11, that you can eat only 11 bananas per hour. Okay, so you can easily complete this in 4 hours. So if you see that at minimum, okay, for this 3 you need 1 hour, for this 6 you need 1 hour, for this 7 you need 1 hour, for this 11 you need 1 hour. Okay, so you can easily complete it in 4 hours. Or but suppose our speed is something like 11. So 3 plus 6 9, 9 plus 7 is 16. 16 plus 11 is what? 16 and 11, it will be 27. So total 27 bananas. We can eat 11 bananas per hour. So first hour we eat 11 bananas, second hour we eat again 11 bananas, and the last hour we can eat 6 bananas. Okay, not 6, 5 bananas. Now this comes to 1 hour, this comes to 1 hour, this comes to in 1 hour. So we need 3 hours, and this 3 is less than or equal to this h. So this is our answer, but this is not the optimal answer. We have to, why? Let's just check it. So if if suppose k is 4, so in the first hour 3 we can easily eat 4 bananas. We can easily eat 4 banana 3 or 4 bananas here. It is 1 hour. Then again in can eat 4 bananas, we are leave with 2 extra bananas, and we just, it is, give me a minute, like 3 6 and then or don't take this, total we have like 27 as we calculate previously. Now we can eat 4 bananas in an hour. So in the first hour we can eat 4 bananas, in the second hour we can eat 4 bananas, in the third hour we can eat 4 bananas, in the fourth hour we can eat 4 bananas, in the fifth hour we can eat 4 bananas, in the sixth hour we can eat 4 bananas, in the seventh hour we can eat 4 bananas. Okay, And now how many bananas? 4, 8, 12, 16, 20, 24, 28. Okay, so in the last hour we have to eat 3 bananas. So how many hours? 1, 2, 3, 4, 5, 6, 7. So total is 7, which is less than 8. It is possible. So we can get a value with 11. Also we can get a value with 4. We have to return the, for this example, 4 is the minimum one. Okay. So how we could actually check this? Okay, how actually we could check this in every time? So if you come here, like it's one pile per hour at a speed of apple per hour or banana per hour. A small piece still burn the full hour. Okay, finish all piles with 8 hours with the smallest key. This approach tells us this one. Give me a minute. This one. We are given the piles, which is bananas, and also we are given the H, which is the hour that we actually need. Okay, the piles, the hours. And we start from K1 to the end. And you could tell like why start it from the 1? Because we need the minimum values that can the Koko eat, the minimum values that the Koko can eat, it's simply 1. Okay, at minimum he or she can eat 1 banana at a time. So start with the 1 for the end. For every time we check hours. So what happens here is simple, like 3, 6, 7, 11. So 3, 6, 7, 11. So if k equals to 3, so we can easily complete it in 1 hour. For this 6 we need 2 hours. For this 7 we need 3 hours. Okay, so you may tell like why 3 hours? Because in the first hour Koko can eat 3. In the second hour it again can eat 3 bananas, but there is 1 banana left. So for this 1 banana also we need 1 hour extra. Actually it's mentioned here, a small piece still, a small pile till burn the full hour. Okay, so this is how we could actually take it. So start with k. So if k is 1, then this remains 3 hours, this need 6 hours, this needs 7 hours, this need 11 hours. Okay, simple. So and how we calculate this? We calculate it with this formula, which is pile by k, and we have to take the ceiling value and sum them up and put it into the hours. Okay, and simply if the hours is less than the age, that is our minimum value. Okay, and the minimum, actually we need the minimum to be our answer. So this is our k1, and if you see it is 27, but we have to do 8, so we don't do it. For k2, this 3 need 2. See, this 3 need 2 because in the first hour it eats 2 bananas, and the second hour it eats 1 banana. That is the maximum thing. Okay, for that reason we actually need like we need to make sure that we take the ceiling value. Okay, so for this case this is happened. For k is 3, this is 1 hour, this is 2 hour, this is 3 hour. Actually I explained it take 3 hours, and this 4, it will also take 3 is 9, and again 3, so it is take 4, and this is 4 simply, and total the sum is 10 less than. For this k, for this k equal 4, This takes 1 hour, this takes 2 hours, this takes 2 hours, this takes 3 hours. Okay, so I don't explain this. So this 3, 6, 7, 11. K is simple 4. So for this it takes 1 hour. For this it takes 2 hours. Simple. Why 2 hours? In the first hour it will eat 4 and the second hour it will eat again the 2. For this 7 it will again take 2 hours, because for this first it eat 4 bananas, then 3. For this 11 we need actually 3. Why? Because first it eat 4 bananas, then it again 4 bananas, then so 4 plus 4 8, so 8 minus 11 is 3, so it take again the 3 bananas. Okay, so this is how. So 1 2 2 3 4 4 3 7 and 8, and this is our actual answer. So our h is actually 8, and these two are equal. These two are equal, and these two are equal, so we get our answer. And we start from k equal to 1. That's mean the first thing we ever reach is our answer. Okay, so I am just taking this and just pasting it here. I will not code it, and it will not work for the answer also, for the question that is given to us in the constraint. It is not work, because it will have a big of n into m time complexity. For that it will not work. Optimize it with binary search. Maybe now the question is why and how we can apply binary search. We don't apply binary search on this array. Then how or where? So at the starting, when I am explaining everything, I first took one value, that is 11. And if we have 11, we can do everything in like 4 hours, because it takes 1 hour, it take 1, it take 1, it takes 1. So everything really in 4 hours. Simple. And let me take it. So this is our simple pile of bananas, and this is our actual size. This is our actual size where we have to make sure that it doesn't increase this 8. So, and one thing you could understand, that if I take 11, see, if I take 11, which is highest among all of this, we can easily complete it in like 4 hours. Okay, because in the first we eat 3, in the second we eat 6, in the 7 we can easily complete it. Okay, from where we start to search in our brute force approach? 1, because at minimum Koko can eat 1 banana. 1. So our maximum is 11, our minimum is 1. And what is the answer for this array or for this pile? 4. Thus 4 in the middle of this 1 and 11. So if we put a low here, a high here, we can easily found 4 in log n time complexity. We check this in our previous binary search class. Okay, the link will be in the description. So we can easily get the 4 which is in between them, and we can apply binary search this in between this 1 and 11. Okay, so this technique is called binary search on answer. Our answer ranges from this 1 to this 11. Our answer ranges from this 1 to the 11. Okay, we have to find the minimum value which satisfy the condition. So do us we can easily apply a binary search. But you may wonder why high is 11 and why low is 1. So the minimum number of bananas that we can eat in 1 hour is 1, because we don't take 0 here, because if it doesn't mean any sense. So we need 1. So our lower bound started with 1, and the higher side is 11. Why 11? 11 because of one reason. Because at max, see, what is the maximum value in between these four? 11. So if Koko can eat 20 bananas every hour, he can easily eat the whole thing under this time. Yes, it can do it in 4 hours. So, but like yes, it if it take 20, then it easily capture all of this. Why? Because we need 4 as minimum, and if it is 15, then simply it can also eat the whole pile of banana. Okay, at max, like I just told you, like 11 is the maximum among these 4 or among this array. So if Coco can eat at most the maximum amount, he or she can completely eat the whole pile of banana within permissible hour. Okay, so for that reason we take 11. 11 is not 11, it is the maximum value of the pile. It is simply the maximum value of the pile, and it is nothing like with 11. And we just put a simple binary search among this, and we have to calculate when we have to, like, first we have to do a mid, like, okay, let me try it. So our low is 1 and our high is 11, so it will be like 12 by 2, which is 6. So for 6, can we do everything in this 8 hours? 3 1 hour, 6 will take 1 hour, the 7 will take 2 hours, this 11 will take 2 hours. 2 to 4 5 6, so total hour is 6, and 6 is less than 8. So it simply means that we can easily take this 6, but we need the minimum value. So suppose we have to make sure we make an answer like this. We have to make an answer which for this mid value or 6, that yes, it is possible with this mid. And whenever we have a possible solution, we have to reduce our high to mid minus 1. So this is our current high, which is 11, which is 5, mid minus 1. This one. Now calculate the mid, which is 6 by 2, and how 6? 1 plus 5, 6. 6 by 2, 3. Okay, so does 3 satisfy this 8? So we previously calculate this. For this k, it doesn't satisfy. So if the value doesn't satisfy the values, simply go and make it mid plus 1, 4. Okay, now 4 plus 5 by 2. 4 plus 5, 9. 9 by 2, we take only integer part, which is 4. And 4 is our answer. And just update this 6 with 4. So our answer will become 4. So this is our simple way. First, let me write it. Let me write it first. So understand why we actually get this high. So suppose 1, 2, dot 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 dot, dot 11, then 12, then dot 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 dot. So it is the highest value. So every value in between them could be make an answer, because this value can along take the maximum element in 1 hour. So 11 is our maximum element. This 11 can take maximum element in 1 hour. So rest of this portion also take 11 in 1 hour, because if Coco can eat 12 bananas, it simply means that it can easily eat 11 bananas in an hour. If its capacity will become 12 bananas to eat per hour. So for that we take the highest value of the array. Okay, highest value. So we are given a thing which is given piles and h. Let's take it as h. So we start with L1 and our high will be of max of piles. So simply do our while loop as our binary search. Okay, so calculate mid and with this formula so that we don't need to make sure that we do a long although in this question I think we might do a long but this is okay. And calculate like if the sum of ceiling value of by mid. And what is pile? Pile is each and individual value like this 3, like this 6, like this 7, like this 11. So the total is piles. So everything is a pile. Okay. So if it the sum value is less than equal to h, then simply do answer will become the mid, and we have to go to the more left part so that we can get a minimum value which is mid. The high will become mid minus 1. And and if nothing happens or the value is much more smaller, then it cannot satisfy the condition, so it will become mid plus 1. And at the end simply return the answer. Let's just check it. Yeah, it's worked. So not this one. This is our pseudocode, or actually this is our code. Can I explain it here? Because it's not that simple, but it's okay. Let's write it. We have our suggestion here. If I do any mistake, you can check this out. This is the actual code, which is right. See this? Okay. This is the pseudocode. Why I take ceiling? Okay. Maybe the question is why ceiling value? Yes. I don't explain this. So if you read the question carefully, Coco loves to eat banana. There are n piles of banana, and the ith pile has a pile I of bananas. The guard have gone and will come back in 8 hours. Wow, the question is good. The Coco can decide she. I many time actually mention he. It is wrong. Apologize for that. It is she. Coco can decide her bananas per hour eating speed as k. Each hour she chooses some pile of banana and eat k bananas from the pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during these hours. Okay. Coco likes to eat slowly but still want to finish eating all bananas before the guard comes. Return the minimum integer k such that she can eat the bananas within each hour. Okay, not here. Thing. If the file is you still if the pile has fewer bananas than your speed, you still spend each hour. So take k as 3. So okay, take k as 3 and for this 7. Okay, so if we do like a simple division 7 by 3, if we do an integer division and take a floor value, it will give us 2. But if we take integer division and also if we make sure that it will give us a ceiling value, so this is the sign for the floor values and this is the sign for the ceiling value, so it will give us 3. Okay, the next integer. Why? Because actually it lies in the first phase. small pile till burn the full hour. Okay, it means one thing also, like in the first hour Coco eat 3 bananas. In the second hour it she will again eat 3 bananas. How many bananas current banana? But for this one banana also she need to spend one another hour. So it will take 3 hours to complete this 7 bananas. For that we take the ceiling value, so that we don't have to make sure that every time we just make any mistake with this. This is one of the mistake I make when I first actually solve this question, like why we need a ceiling value. Because in the first hour Coco will eat 3 bananas, in the second hour she will again eat 3 bananas, but for the third hour she will eat 1 banana. She will eat 1 banana, but it takes another 1 hour. You will take 1 banana, but it takes another 1 hour for her to completely eat the bananas. It takes her 3 hours to complete 7 bananas. So that is the reason we are taking like the ceiling value everywhere. See in the code, we take the ceiling value. Okay. So why this double? This double so that we can get easily answer. So for this ceiling value, focus on this. This pseudocode, and now let's write it. So first we have to make sure we take these two. Okay, so let's take it. First take the size. Actually it is, can I take it? Actually I don't need to take the size. First take the answer, initialize with -1, that it is possible or not, and we need to find out a low. Take it as low. Low will become 1, and we have to find out a high. We a file, and we can do it like this: max element pils piles dot begin. And so actually this is a inbuilt function which goes and take the maximum element from this whole array or vector, and if we just take it as mean, it will give us the minimum element. Okay, so this is how we can actually get the maximum element. We don't need to traverse it again, but you can make sure that you can use a traverse of for loop for the traverse of the whole pile and take the maximum. So this will become our search space or our answer space. Now apply binary search while low is less than high. While our low is less than high, simply do one operation. First calculate mid. Our mid will become low plus high minus low by 2. So this is our mid. And what we have to do with this mid, we calculate this mid here. See, we calculate this mid. Now we have to go and check everything in the pile that it do it or not. So we can write a function for it. Let takes in age, take hours. It will return an hour. Can you do it like is valid? I don't have what the function I use. Calculate sum. Okay, calculate total hours. Let's take it. Be good with naming functions. Okay, it will help us. Piles, and we take this mid. Okay, it will return us this value, this sum of ceiling or this pile and the mid. Okay, so now check if the hours is less than equal to hour or not. So see, this is our condition. It is less than equal to h or not. Simple. If it is, then the answer will become the mid and the high will become mid -1, and the else, that if it is not less than hour, so we actually reach a very small portion very small portion where the numbers doesn't lie. So we have to do low equal to mid plus 1. Simple. And at the end, return our answer. Now we have to write down this function. Int, take this. It will take it as k because it can eat k. So we have to find out the k. So take k. Uh, because it is mentioned like k banana. So we take with k bananas, that is k, this k bananas is possible or not. So how we should search it? And simply do a linear search. Int n equal to size, and take an like hour starting from 0 for int I equal to 0, I less than n, I plus plus. For every element from the start to end, simply run one thing. Simply hour plus equal to files of I by k. Okay, so see it. Same thing, but we have to take the ceiling value. Okay, just write CEIL. It will do its, but it can give us wrong answer. So we have to just return our, yeah. Let's run it, and it can give us a wrong answer, but not the syntax error. It every time it gives a wrong answer. Why? Because the calculation is not. So whenever in C++ you do this kind of calculation, try to make sure it will take a double. Okay, because for this double, see here the answer is possible. I just check it. I just give me a time to check this. But you have to make sure that you will do a double. Why? Because if you don't do double, it will do an integer division. It doesn't do anything. But for double, it, so the problem is, let me check. The problem is simple. So if we divided 7 by 3, the answer will always become 2. Okay, but if we ever divide 7.0 by 3, so okay, not this, oh, one. So first it will do one thing. First it will divide it. So let's divide 7 by 3, or rather take my calculator. 7 by 3. What is 2.33333? So it will first take 2.33 and do its ceiling. So for this case, it will take this ceiling value of 2, and it is a decimal, it is an integer, so it will take 2. And for this case, this is simply a double value, so it will answer 3 because of this point against, because it is nothing but 2.00, and 2.00 the ceiling value is always 2, but we have to increase, for ceiling value. For that reason we have to take this 0. Okay, so by far it is not 3, it will become a 4, it will be a better, or 3 because 2.3333, so it is become a 3. So that is how we need this double. And why? I think our range, every pile's value content 10 to the power 9 at maximum. So if we simply do a long, I think it work. Long, and even for this hour, take the long. I think now this should work. Because of this high value, this may cause an error, but it still cause an error. Okay, let me check. Um, Does it did any mistake or not? Okay, let me just check and come to you. Simple binary search mistake I did. Because maybe low and mid can be with the same values. I think for this thing, if the hour is 5, let's just check it. Let's do a dry run. Okay, so this is our array. Let's do a dry run. Let's do it. I know the video is lengthy, but let's do it. And the hour is 5. And the hour will become 5. So for this, what is the maximum value? The L will become 1 and the high will become 30. Okay, so what is the mid? 31 of it will be possible. Simply our mid will become 31 by 2, which is simply we are doing integer division, so it will become 15. So for 15 this will take 1 hour, sorry, for 15 this will take 2 hours, it will take 1 hour, this will take 2 hours, this will take 1 hour, this is 2 by the way, and this will also take 2 hours. Okay, so 2 to 4 6 7 8, 8 is not possible. So when we don't get a possible answer for 15, we increase our low will become 16. So 16 plus 30, 46. 46 by 2, it will become 23. Just did it for 23. For 23, it will again take 2, it will take 1, it will take 1, it will take 1, also take 1. So 2, 3, 4, 5, 6. Okay, it is still not possible. So we have to increase it to 24. So increase it to 24. Now 24 plus 30 is simply 54. 54 by 2, 25 and 26. 26. For this 26, it is also not possible, because it will give us the same. See, everything will be the same for the 26. It is not possible. It will become 27. Okay, I think we need 30 here. So if 27 plus 30, it will become 57. 57 by 2. Let me do it. 57 by 2. 28.5. It will give us 28. For this 28 also it is not possible, because it will give us same answer. So we have to take 29. But 29 plus 30, it will simply become 59. 59 by 30. 2. So 59 by 2 is 29. Okay. So it is 29, but it is still not possible, because for 30 it need 2 hours, because 29 for 1 hour and 1 for another hour, and rest of the thing will happen in 1 hour. So 29 plus 1, 30. 30 plus 30, which is simply 60. So our mid will become 60 by 2, which is 30. And for this 30, this will become 1. So 1, 2, 3, 4, 5, it is possible. Yes, but because in the output is 30. See, we got our output 30. We don't uh, we actually forget to mention this equal to, and for that when it is going to equal to like L equal to 30 and H equal to 30, it give us a wrong answer. Okay, and you use the long here because it is a like a heavy value of 10 to the power 9. So when you add many values, and if the size, the length is also like less than H, or 10 to the power 4, but if we add 10 to the power 4 element, or which individual value is 10 to the power 9, it may exceed the integer range. So for that, long hour would be a better option. So again run it. So use a long here, and don't forget this equal to. I try run it for that equal to. Yes, so this is our solution for this Koko Eating Bananas or apple harvesting. Many variant come and here also. So see here in this pseudocode, here we just loop through everything, so it will become big O of n into m. Okay, but if you see here also, even it is mentioned here that here we just use a binary search rather than that normal linear search. So our complexity will become, our time complexity will become big O of n. Okay, n will be there, but it will become log of m, and m is our answer space, where we are m is the length of our answer space, or the space of the answer, like from 1 to 11 or 1 to maximum value, and n is simply the size of the array. And our space complexity will also become, we don't use any extra space. I think big O of 1 is okay. Yes, big O of 1. And time complexity is big O of n log n. It is much more better, and it will accept this solution. Okay, so go solve this question. Use this platform. Go and use this link to get a 7-day free trial. Okay, to get a 7-day free trial on this platform. And even you can actually remember this thing also. Ending the video, I got this. Yeah, why binary search works here. If you have any question of binary search work here, because the answer is always in a monotonic pattern. If you just go and check the previous value or the brute force approach, where we just increasing at every value, so it is a monotonic pattern of increasing values. So we need, and the normal search is too slow and make it invalid. Okay, so and the sum part, like if we take 20 and our maximum value is 11, it is invalid, because the maximum could be that is 11. The maximum always become 11. Okay, and you may ask, like maybe there are question where we take that's the previous, like the previous dry run which we did, the maximum is 30, we get 30, and also the value of the h is 30, h is 5. So you may answer, it may give us h3, and which is not possible. It will not, because if you see here, the pile length or the length of the total pile is always less than the h or equal to the h. Always it is given in the constraint. It simply means there, if you take the maximum value, it take the n hour. If you take the maximum value, it take n hour to eat, because each of them is taking 1 hour to eat. And for that, our n, which is the length of the pile, will become h, and it is always become h. Okay, so we simply find the we simply want to find the first valid speed, the first one. Okay, so for that, using this monotonic pattern, which is monotonically increasing, like it is 1, it is 11, and it is monotonically increasing. Speed that are too slow are invalid. So suppose this is our answer. Okay, so this too slow, this all are invalid, and this one we don't need this, because the point far from the point onwards, all speed are valid. So we have to find this bit. From that to everything is valid, and from that to behind not a single one is valid. We need to find this. Simple. So this is our point. Go check this. I have write the whole code. Okay, use this link to get a 7-day free trial. Use this platform at dsa.chaicode.com. Thank you very much.